Okay, hello everybody. A big hello to everyone who's rolling in just now. Welcome to this live office hour for Precalc and Trig. My name is Steve Chow. I'm Black and Repent, of course, as many of you guys know me. And today the goal is to help you guys understand Trig and Precalc. And I'm partnering up with Check to help you guys learn better. And for those of you guys have been here for the first time, yeah, welcome back, welcome. And you can just think about this event is like a virtual office hour. I'm here to help. So if you have any questions, don't be shy. Just put it in the chat and I will try to answer them. Okay? So to start off, I have some icebreaker questions to help you guys with. I prepared this, right? Today we'll just see how to do some trig identities, which if you are taking trig or pre-calc, then this will be hopefully helping you. And of course, you guys can ask me questions later on. Okay, so let's do the first question. And these are the identities that you will need to know, by the way. Firstly, let's see if we have sine x, and then we add cotangent x times cosine x. This right here is equal to what? And I'm going to give you guys choices, all right? So the first option is cosecant x, and then option B, we have secant x, and then option C, we have cosine x. So please go ahead, and then I'm going to be looking at your answers as well. So I give you guys like 20 seconds or so. Go ahead and try the question and then drop your answer in the chat. Yes, this right here is with check, and then we are doing trig and precalculus. You can just think of this as like an online office hour. Today we're doing trig identities. So I have some questions prepared, and I will also be taking your questions. And please keep the topic regarding trig or precalc. Any questions? Okay, so we have a few of you guys say A. Okay, anybody said something else? Just the first question, right? This is we have like a couple more, and later on you guys can ask me questions. So the answer, I don't know yet. I will have to work it out. So this is how I'm going to work this out. So one strategy is you want to write everything in terms of sine and cosine. That's the first thing, right? So perhaps I will just write this down right here for you guys. One strategy is try to write everything in terms of sine and cosines. Usually they'll work really well, and then of course you have to use other identities. So if you look at the first thing, we have sine x right here already. Cotangent, you have to know your identity. Cotangent is cosine over sine. So this right here, go ahead and write it as cosine x over sine x. And then right here we have another cosine x. So that's the first part. Okay, what else do we do? Yes, we can multiply the cosine x together. So this becomes sine x plus cosine square x over sine x. Okay, and then what else can we do next though? Multiply sine x with sine x over sine x, correct? Because now we have two things, right? We want to combine them, and to do so, we can just use the common denominator. So right here, let's go ahead and multiply the bottom by sine x, and then let's do the same right here as well. So we have sine square x over the same denominator, so just write it down once, and then plus cosine square x. Aha, you guys are right. This right here is very nicely equal to 1. So finally, we just have 1 over sine x. So this right here is just going to be cosecant x. Yes, for the people who said answer choice A, this right here is correct. Right, this right here is correct. Okay, so this right here is like my first question, but I will right now take a look at the chart. For the people who just turned in, Welcome. This is the online office hour with Jack, and today we are focusing on pre-calc and trig. So if you are taking these classes or any questions regarding trig and pre-calc, you guys can ask me. And in the meantime, I'm going to erase the board, and then I will look at your chat to see if there are any questions that I can answer for you guys. And how's everybody doing right now? For me, it's 6:50 p.m. And then we will be doing this live next week as well from 6:45 p.m. Pacific time. We will last an hour until 7:45. All right, so where are you guys from? The job, where you're from, let me know. And what time is it in your place right now? Okay, I have a question right here. We have this right here. We have sine x plus cotangent x. So here we have sine x plus cotangent x. And then we are going to multiply that with sine x minus cotangent x. Let me just make sure. Okay, so let's see. For this one, I think we can multiply it out and see what happens. And especially we can see that this right here is in the form of a plus b. Let me change the marker here. A plus b. And then we multiply that with the same thing, and then with a minus, so it's a minus b. So we get a squared minus b squared. So the fast way to multiply this right here is just that this is equal to this thing squared, which is sine squared x, and then minus this thing squared, which is cotangent squared x. So that should be the first move. Just multiply it out. Okay, and then again, let's do what we did earlier. Let's turn the cotangent into cosine over sine, and this right here is squared. So we get sine squared x minus, we will have cosine squared x over sine. It shouldn't be fancy. I'll just write everything red like this, because this thing is cosine squared x over sine squared x. Okay, and then perhaps let's just get a common denominator right here, right? Okay. Prove the half angle identity. Maybe later on after this right here, because I'm trying to finish this right here. So let's multiply the top and bottom by sine squared x. Okay, so together they will have sine squared x on the bottom. And then on the top though, we have this right here. So sine to the fourth power x minus cosine squared x. I wonder, like, what else can we really do with this? Because once we multiply it, we get this, and then what else can we do to like really simplify it? So was that just the answer? Or should we keep going? Because sometimes you don't know if you should keep going or you should just stop. So okay, so well, we can try this thing right here like this. We can say this was sine squared x, right? Minus, if you turn this into 1, minus sine squared x, and then over sine squared x. Okay, and then this becomes, if we split this, we get sine squared x, and then distribute the minus. Yeah, distribute the minus, and you will see this is minus 1 over sine squared, which is cosecant squared x. And then this over that is just 1. And then minus times minus is plus. So we have this plus 1. And yeah, like what can we really do next? Yeah, not much to do, to be honest. I think maybe the question was just you wanted to multiply to here, because I really don't see if you should keep going, because I don't really think any nice identity that we can simplify. Yeah. So let me see what else can I do with that. Okay, wow, I got a lot of chats, so I'm sorry if I cannot get to your question. And for the people just turning in, welcome, welcome, welcome. And I see people are all from the world. France, yay, and then Colorado, wow, Brazil, Kansas, Lebanon, California. Okay, I'm going to take some questions from Trig. And I think I'm just going to stop right here because usually I like to ask like multiple choice questions so that I know if I have to keep going or I can stop. Okay, I'm sorry, like so many messages. Okay, we are not doing calculus right here. Okay. Prove the half angle identity. Yes, I think I can do that. And I do have my little sheet that I prepared for this live stream. And again, this is, you can just think about this as like an online office hour. I'm partnering up with Check, and today we are doing Trig and Precalc, and we'll be live again next. So if you want to prove the half angle identity, okay, which half angle identity? Okay, maybe we can do this right here. So here's the deal. If you have cosine of 2 theta, so let's start with a double angle identity. This right here, what we are going to get is you have 3 versions. You can get this as cosine squared theta minus sine squared theta. Okay. And then if you use the Pythagorean identity, which is a super common identity, I should write it down right here. It deserves a special spot. Seriously. Sine squared theta plus cosine squared theta, this right here is equal to 1. And you can kind of just move things around. For example, you can say 1 minus sine squared theta gives us cosine squared theta. Or you can also say this as 1 minus cosine squared theta equals sine squared theta. And then you can use whichever one. So if you replace this right here with 1 minus sine squared theta, and that's my number 2 right here, if you look at it backwards. And then we have minus sine squared theta. Together we have 2 of them. So this right here is 1 minus 2 sine squared theta. And now if you want to prove the half angle identity, what you want to do is you are going to get this is equal to that, right? So let's do this again. Cosine of 2 theta equals 1 minus 2 sine squared theta. And then if you want the half angle, what we are going to do is, let's write this. Let theta equals, let's use capital A for something. Let's say A over 2. Then you will get this right here being cosine of 2 times A over 2. And that's equal to 1 minus 2 sine squared of A over 2. And we are about to get the half angle right here. And then you can see that this and that cancel. Now we are going to move things around. We are going to, let's move this to the other side and then move this here. So if we put this to the other side, we get positive 2 and then sine squared of A over 2. Right, A over 2. And that becomes positive because I move it to the left-hand side. And then this is equal to 1 minus cosine A. So now you see we have A over 2, and then right here it will be in terms of cosine A. And then we can divide the 2 to both sides. So I'm just going to divide it right here, cancel, cancel. And we are about to run out of space, so I'm going to erase this right here. And then just kind of look up right here. Here, we will get sine squared of a over 2 equals 1 minus cosine of a over 2. So whatever this a is, it will be right here, right? And then to get the sine part by itself, we can just go ahead and take the square roots to both sides. But remember, whenever we take the square roots to both sides, we have to put the plus or minus. So let's do that here. And ladies and gentlemen, here we have our sine of a over 2 being equal to plus or minus square root of 1 minus cosine of a over 2. Ta-da! That is our half angle identity. Okay, that is our half angle identity. Okay. Okay. Another one. So sine square of 6x. Okay. A lot of messages are coming. That's cool. A lot of people are joining. So welcome everybody. For the people who just got here, this is the online office hour with Check, right? And today we're doing trig and precalc. And I'm going to try to prove that one. So here, I'm going to erase this. Okay. I don't want to miss the question. So sine square 6x. Okay. Sine square of 6x. And then we are going to minus sine square of 4x. Okay. So I'm going to try my really best to go from here, and then our goal, this is the goal. Our goal is to end up with sine of 2x times sine of 10x. Okay, so that's the question. So right away, I'm just going to factor it with difference of 2 squares because we have the square. So we have the square here, and then it's a subtraction, right? So I'm just going to factor with the difference of 2 squares. So this to me, I'll just go ahead and do sine of 6x minus sine of 4x. And then we are going to multiply this with sine of 6x, and then plus sine of 4x. Okay. I don't have this formula prepared. The formulas when we have to do sine of 2 things. So here's the formula that we will need here. We will need to see how to add these 2 things together, and then notice that we have a subtraction. So we will need to have the formula of sine of A. Just erase that. We need a formula for sine of A minus sine of B. And we need to get a formula for that, and then we need sine of A plus sine of B. And then if we have the formulas, then we'll be pretty much done. Okay, I think I can prove it, but just to save time, I'm going to look that up real quick on my notes on my computer. Okay. Okay, so the one I see right here, I have this being equal to 2 cosine of A plus B over 2 times sine of A minus B over 2. And then if I have a minus, I have a plus, then it's kind of like the other way around, but very similar. This is 2 sine of a plus b over 2 times cosine of a minus b over 2. Okay. Why do we have the cosine? Well, I think I'm just going to go with this and see what we can do. And then maybe I can take a look at you guys. Oh, thank you. You guys told me the answer too. I should have just looked at your chat earlier. Oh, so I'm going to rewrite the question right here. The question is sine square of 6x minus sine square of 4x. Yeah, and then we're trying to show that this is equal to that. And right now, I have this right here. Okay, let's keep going. So, for the first part, A is the 6x and B is the 4x. So for the first part, I'm going to do it in red. We will have 2, and then we will have cosine of A plus B. So we will have to add them together and divide it by 2. So 6x plus 4x, that's 10x. Actually, I'll show you guys all the steps. 6x plus 4x, and then divide it by 2. And then times sine of 6x minus 4x divided by 2. So that's the first part. And then the next part is this, and then we pretty much do the same thing. So 2, and then we have sine. I am about to run out of space, but I was trying to fit this in. So we have 6x plus 4x. Over 2, and then cosine of 6x minus 4x over 2. Okay, so now let's see what we have. Firstly, 2 times 2 is 4. I already don't think that, I don't know, but 1 second, let me just see what we have. This is cosine, that's 10x divided by 2, so we have 5x. And then this right here is sine of 2x over 2, which is just x. And then we have another sine, and that's 10x over 2, which is 5x. And then that's cosine of 2x over 2, which is just x. So that's what we have. And then I think I see what's going on. Do you guys see it? Okay. So far, we are on the right track. Okay, even though it might not look like it, but we are on the right track. I will provide the stats for you guys. So let's just go ahead and focus on this part right here. Remember, our goal is to show this. So right here, we have this, right? So I'm going to go back to here. Now, I'm going to utilize the double angle identity. Notice we have sine and cosine. So here's the note for you guys. Note. If we have 2 sine x times cosine x, this becomes sine of 2x. So instead of this 4, I'm going to break them apart into 2 and 2. So right here, I'm just going to look at this as 2, and then I'm going to have cosine of, actually, I'm going to do this. Have a look. I'm going to first break down the 4 right here as 2 times 2. And I'm going to pair up the sine x and the cosine x, because I have it here, and I also have it here, right? So it's 2 sine x, cosine x. And then, again, we have another 2 right here, right? So this right here is another 2. And then we have the cosine 5x, sine of 5x. So I'm going to write it as sine of 5x, cosine of 5x. Now, we're going to kind of merge them together by using this identity, which we can just combine all that to become sine of 2x. That's exactly what this identity is. Then, this right here is just going to be sine of, the angles are the same, right? The 5x. And then you just have to do double of that, which is going to be 10x. And that's exactly what we wanted. So we are done. Okay. Let me see. So for the people just coming, thank you guys for turning. And then this is the online office hour, the virtual office hour with Check. And today we're talking about trig and precalc. Okay, so let me see. Oh, a lot of people are participating, answering the question that we were doing earlier. That's great. Perhaps I'll give you guys one question for you guys to try out that, just to do this real quick. Okay. Because I do have some questions prepared for you guys. So let's try this one, number 2. Let's do this. If we have cotangent x over, then let's say we have cosecant x minus sine x. And you know how I like to do it. I'm not going to ask you guys to prove this is equal to whatever because I'm telling you the answer already. Instead, I like to put in a multiple choice. So you will have to do whatever you need to do, and you will be able to see if you have to stop or keep going because you have to get the answer choices, right? So, couple questions for you guys. The first one is, oh, sorry, the QR code is blocking. Let me just write it down right here. So let's say this is my second question. For you guys, we have cotangent x over cosecant x minus sine x. Okay, A is tangent, B is cosecant, C we have secant. All right, so what do you guys think? In the meantime, I'll be looking at the chart. Okay, so we're not doing calculus today, and prove sine square x plus cosine square x is equal to 1. You mean this right here? I can do that real quick later on. And let's see. De Moivre's theorem proof. By induction, yes, I can do that. So let's see. I'm going to do this question first. So A, B, or C? Okay, the majority of you guys, pretty much everybody that I see is secant x. Let's see if we got this right. So again, the strategy is we're going to write everything in terms of sine and cosine. So for this right here, write it as cosine x over sine x. And then over, this right here is 1 over sine x. Wrong color. And then minus sine x. So that's the first change that we shall make. Next, we have a complex fraction. I'm going to multiply the top and bottom by the common denominator, which is just sine x. So let's go ahead and do this. And let's go ahead and do this. You can also add this by combining them, well, technically subtract, combine them by getting the common denominator and go through that. By the way, so if you do this, then you'll see that this and that cancel. On the top, we have cosine x. On the bottom, distribute this, distribute that. That's 1. That's minus sine square x. And I think many of you guys noticed that we'll be using this over and over again, right? So this thing here on the bottom is just cosine square x. Okay. And then you can see this cancel with one of them, so you get 1 over cosine x. At the end, we will have secant x, and that is answer choice C. That is answer choice C. And I'm going to just explain real quick why this identity is the way it is. But take a look, and I'm going to erase this real quick. So my purpose here today is not only to give an opportunity for you to ask questions, but also I'm also trying to make learning engaging and enjoyable. And I will be here next week as well. Yeah, during the same time, 6:45 p.m. Pacific time, and the live stream will be an hour. And thanks for Check for partnering out with me for holding the Trig and Precalculus online office hour. And if you have any questions on your mind right now, or anything that you're studying, check out Check. You can check out Check. They have a lot of tutor subjects that will help you with your studies. Okay, by the way, there's a QR code. You guys can scan that, so you can check out more information from Check. And then I'm going to prove the identity here. Not like proof though, but rather explain why that is true. Here is the reason. Yeah. So if you look at the unit circle, this, that's a unit circle. One, it's a unit circle. Just unit circle. Firstly, let's think about the equation of a circle when the center is at 0, 0. In fact, just x squared plus y squared is equal to 1. So the equation for this is just x squared plus y squared is equal to 1. This is the equation of the circle with the radius equal to 1. Technically, 1 squared, but 1 squared is just 1, so there's no need for that. Now, you have to know the definition of sine and cosine. Once you know that, you see this right here is going to be median right away. So the definition for sine and cosine is that if you have a point on the unit circle, first, this is how we are going to measure the angle. We are going to rotate so much so that we can kind of get to here. And we are going to call this angle theta. And then we get to this point. This point will have the coordinate. The x is going to be cosine theta. And then the y is going to be sine theta. That's it. And in fact, you just proved this Pythagorean identity. Why? Because this right here is the x value, this right here is the y value. Throw them in. Put this right here, you will have cosine, theta, I'm using theta. And then I'm going to square that, plus, right, the x is this, and then the y is that. Put that in here. Sine theta, and then square, this is equal to 1. And congratulations, here we have it. Cosine squared theta plus sine squared theta, this is equal to 1. Perhaps the most common trig identity that you have to use for your trig and precalculus class, and also calculus, of course. Okay. And then maybe you have seen another proof like this. I will also do that for you guys real quick. If you have a right triangle, you can look at this from the right triangle point of view. Let's say here is the angle theta, and let's say here we have A, B, and C. The reason that this is called the Pythagorean identity is that if you have a right triangle, then you can just go ahead and use the Pythagorean theorem, which is, of course, A squared plus B squared equals C squared. Now, I'm going to divide everybody by C squared. This right here is A over C squared. This right here is B over C squared, and that's equal to 1. Now, as I mentioned earlier, we call this angle theta. A over C is opposite over hypotenuse. So this right here will give you sine theta. So we have sine theta and then squared. And then B over C is adjacent over hypotenuse. So we add cosine theta and then square, and this is equal to 1. Pythagorean identity. And now I want to mention that when you have the little 2 exponent here, this means you have cosine theta squared. This means you have sine theta and then square, right? It's just a notation that you have to really kind of get used to. All right, welcome everybody. And then maybe let's go ahead and get into some other questions that I prepared for you guys. Let's do another one real quick. How about let's do this? This is going to take a while. Actually, let's do this. I have number 6. Let's do this one right here. This is my number 6. I actually just write down the question because I want to make sure I take other questions as well. But this is also the one that I think you should really know, especially if you're taking trig and precalc right now. This is the type of questions that you will really have to know. We have a secant function, and then the input is inverse sine x. And then we are going to write this as an algebraic expression, and I'll give you options. Option A, we have 1 over square root of 1 minus x squared. Option B, we have x over square root of 1 minus x squared. Option C, we have x over square root of 1 plus x squared. All right, I'm going to pause for a little bit. You guys go ahead and try this right here. And then in the meantime, I'm going to see the comments. Oh, you need help with identifying asymptotes. Okay, I will give you an example for that. Maybe like algebraic. So that will be more like for precalc, there are 2 parts, like the harder version of algebra and also like more trig, right? So that would be more like the algebra side of the precalc. But for now, let's see what do we do with that. So, okay. I'm sorry, there are many questions and many comments. I am sorry that I cannot get through all of them. I'll try my best though. And then check, use the QR code over there. Okay, now let's do this right here. Anybody has the answer though, real quick? Oh, this is a lot of fun. Actually, I don't know how many people are there in the live stream right now, but I see a lot of comments. Great. So a lot of you guys are saying, hey, let's see if this is true or not. So this is how I wanted to do it. I like to use the triangle method. The triangle method. Here we go. This right here, the result of an inverse trig function, it's always going to be represented as an angle. It's an angle. So I'm going to start off by saying that's angle theta. So theta equals inverse sine of x. Then we can do this. I'm just going to apply the original sine to both sides, so that this and that cancel. And then we are looking at sine theta, it's equal to x. And for x, we can write it as x over 1. The reason we do this is because we can use a right triangle for this. The definition of sine on a right triangle is opposite over hypotenuse. So OPP over ATJ. And then draw the right triangle. So I'm going to draw here. So here is my angle theta. The opposite is x. The adjacent is 1. Now we have to figure out the hypotenuse. Let's do the quick way. It's just that you're going to open the square root. If it's hypotenuse, it's going to be the longest side. We are just going to do this squared plus the other side squared. Just like that. And just like that. Now, if you look at this right triangle, and then you are going to do the secant of the angle theta, then you can just do the usual business, right? Secant is hypotenuse over hold on one sec. Did I write this wrong? I think I put... What is this? Hold on. Opposite over. Yes. I got it. Yes. Opposite over adjacent. Opposite over hypotenuse. Sorry. Erase that. I was teaching classes today in the morning. Yeah, in the afternoon actually. This right here is hypotenuse. See, teacher makes mistake too. Now you guys caught me live. Okay, here we go. Let's do it again. Thank you everybody though for helping me. All right, opposite is x. And this right here is the angle theta. Hypotenuse is 1. It's like this. Okay. Now we have to figure out this side. We are going to open the square root first. And then if it's a side, you are going to take the hypotenuse, square that first, and then minus the other side square. Just like that. Now, we're doing the secant, which is what? Which is hypotenuse over adjacent. So secant of the angle theta, right, is this over that. So it's 1 over square root of 1 minus x squared. Again, secant is hypotenuse over ADJ adjacent. So it's this right here. So A. Okay. All right, let me see what else. Oh, asymptote questions. Oh, I think that I am going to tell you about this right, because this right here, if you're taking pre-calc, this is a must know. And also if you are taking calc 1, this is also must know. But it's more like a pre-calc side, right? That's the one that ground spot. So I'm going to just put it right here. Let's focus on the vertical asymptote. So let's see vertical asymptote. That's not vertical. VA versus the whole. And this right here is also called the removable discontinuity, but this is more toward like a calculus term. Removable discontinuity. And that's let's look at this function, for example. Let's say we have f of x. Let's say we have this. X minus 4 over x squared minus 5 plus minus 5x plus 4. Plus 4. Okay. So here is the deal. There are 3 parts that you really have to know. Not just vertical asymptote and the whole. In fact, there's also the domain that you have to know. So 3 things that you should know. Firstly, though, I'm going to tell you guys about the domain. For the domain of a rational function, you have to make sure that the denominator is not equal to 0. So you should right away put this not equal to 0. X squared minus 5x plus 4 not equal to 0. And then just go ahead and solve it. Factor it, x minus 1, x minus 4 not equal to 0. From here, x minus 1 is not equal to 0. From here, x minus 4 cannot be equal to 0. So x cannot be 1, x cannot be 4. Now, you have to pay close attention to which one will give you the vertical asymptote and which one will give you the whole or removable discontinuity. Okay, so which one is which? Which one is which? Which one is the vertical asymptote? Let me just write down this right here. And then which one is the whole right here? Okay, let me see. Yeah, for the people just coming, welcome. And this is the online office hour with Check. And then we are doing pre-calc and trig today. And we'll be live again next week. Same time, 6:45 p.m. Pacific time. And we'll be going live for an hour. Okay, a lot of people are answering the question, which is great. Okay, so 1 is the VA, yes, and 4 is the whole. Yes, you guys got it right. Now, I'm going to give you guys some notes. For VA, I'm just going to write it down here. For VA, meaning vertical asymptote, what you have to look for is, you have to be careful to have non-zero number on the top over 0. Right? Non-zero number on the top over 0. This right here will give you the vertical asymptote. So if you plug in 1 into here, let's see, we have 1 minus 4 over 1 squared plus minus 5 times 1 and then plus 4. It doesn't matter what it is on the top. You see, it's going to be a non-zero number. That's why it matters. But at the bottom, you know it's going to be 0 because we solved that earlier. This right here is an indicator that you are going to get a vertical asymptote. So the vertical asymptote is at x equals 1. So technically, I'm writing at x equal to 1. Right? Yeah. The domain is x cannot be 1, x cannot be 4. Everything else is okay. But the vertical asymptote is at x equal to 1. And then for the whole, usually you wouldn't get like super tricky questions. So I think this right here is all you have to be careful with. For the whole is that you should get 0 over 0, right? 0 over 0 before you reduce, right? Just kind of keep in mind before you reduce. Because the truth is, many of you guys might have noticed this earlier, right? Because if you factor this on the bottom, you have x minus 1, x minus 4. You could actually reduce out the x minus 4. And that is the case, that's going to give you 0 over 0. So that's actually at x equal to 4. So I'm going to just answer that at x is equal to 4. Okay, so these two things will pretty much get you through all that. And then maybe I'll also answer the horizontal asymptote, but make sure you know the domain, vertical asymptote, and also the whole. And then finally, I'll also provide a graph for you guys. So let me just erase this real quick. And perhaps I'm going to erase this right here as well. All right, finally, let's do the horizontal asymptote. This is like a little bonus part. For the horizontal asymptote, the technical way to do it is that, well, in pre-calc, so you should see limits as well. For the horizontal asymptote is that actually, let's do this. This is more like a pure pre-calculus way. Function is just rational. So x minus 4 over x squared minus 5x plus 4. Pay attention to the highest power of x on the top and the highest power of x on the bottom. So the top is just this, and the bottom is just that. For the horizontal asymptote, you don't even have to reduce it. And then you see that this right here has less degree. If the degree on the top is less, degree of the top function, right, the top part, if it's less than the degree of the bottom, what's going to happen is that as x gets to infinity, the bottom will be so much bigger than the top. And when you have the bottom get so big, the whole thing will be super small. So when you have this right here, you just get 0. The horizontal asymptote is just y is equal to 0. If they have the same degree, let's say if you have 2 right here, you just kind of divide out and then just get a number, and that will give you the horizontal asymptote. If the degree on the top is higher, then you're not going to get horizontal asymptote, you'll get infinity. But sometimes you may get a parabolic or linear, like a slanted asymptote. But for this one right here, horizontal asymptote is y equal to 0. So perhaps I'm also going to say at y equal to 0. Whew, just like that. Okay. So I'm going to erase this, and I'm going to take a look at your questions. Yeah, we are live. Today we're live. Just check. And then we're doing trig and pre-calc. This is, just think about this as like an online office hour, and then we'll be back next week as well. Finally seeing a live video of mine. Thank you. It's fun to do live. Okay. Do you guys have any other questions for trig and pre-calc? You guys can just drop it real quick in the chat. And do I ever do office hours on more advanced courses? Unfortunately not. I haven't taught real analysis or abstract algebra, so I'm not expert in that. So I'm sorry about that. My main focus is teaching. I'm a teacher at a community college, and then I also taught high school. I also worked with high school students before as well. So those are like my main focus. And I taught today too, like in my school. So a bit tired, I would say. Okay. Cartesian polar spherical coordinates, that is more like a calculus 3 thing, right? So maybe in the future, today we're doing trig and pre-calc. So give some unit circle tips, please. Which unit circle tips that you prefer though? What do you mean? If you have specific questions, okay, trig question, I'll take that. Why is tangent of, so right here. So why, the question is why, if we have tangent of arctangent of x, why is this equal to x for all x? I'm just saying for all x. This means for all x in the real numbers. So this is more like a mathematical notation because I'm running out of space right here. Why is this true for all x, but not the other way around? But if you have arctangent of tangent of x, this is not true for all x. Not for all x. Okay, so let's see. Firstly, you will have to understand the concept of domain and range. So if you look at the graph of the original tangent function, I'm going to put that down here. So it's going to look like this. So we have asymptotes at multiples of pi over 2. So I'm just going to put down pi over 2 negative and also pi over 2 positive. And then the period for tangent is pi. So this is pi. And then you can do it again. So you have 3 pi over 2. Go the other side, right here, negative 3 pi over 2. And then these are the vertical asymptotes. Now, tangent looks like this. If you just look at that part, that is a one-to-one function, and that makes this part invertible. But if you want to look at the whole graph of tangent, y is equal to tangent x, then it repeats infinitely many times. So you have this infinitely many times. And imagine if I put the board like tilted, right, rotated about y is equal to x. Once after the rotation, you're not going to get a function. So the domain to have inverse. So I'll just write this down. The domain to have inverse for tangent x. Okay, the key right here is from pi over 2. So from negative pi over 2 to positive pi over 2. And then I'm going to just write it as inequality because if I put interval notation, it looks like a point. Not my favorite notation, but this right here, I will just write it like this. Not including the endpoints though, so x like this. Now, if you look at this part, this graph keeps going all the way down and this part goes all the way up. So during this part of the graph, the range of the tangent function, guess what? Why it's all real numbers? I'm going to just kind of abuse the notation. Y goes from negative infinity to positive infinity. I don't know if people really like this notation or not, but it means it goes from negative infinity to positive infinity. So here's the deal. The domain to have inverse is this, and the range is that. When you go backwards, when you do the inverse, the domain for this right here, it becomes the range of the original. So this x could be all real numbers. So whatever x you plug in, it always makes sense. And then when you do tangent of that, they legitimately cancel and you just get x right here. But unfortunately, not when we have this right here. This right here only works. Right now I can tell you, this right here, you can cancel the out. You will have to pay attention to the domain for this function, which is only from negative pi over 2 to pi over 2. So I'll just say only for x in between of negative pi over 2 to pi over 2. And you can also show like a counter example, because if you do, okay, I can also show you guys a counter example for that, and then I will move on to the next thing. And then I think we're almost done though, because it's almost 7:45. So just one real quick thing. So if you have arctangent of pi, what's the answer for this? What's the answer for this? Quick, we only have a few minutes. We're almost out of time, so I want to thank everybody for showing up today though. It's a lot of fun and your engagement, your questions were great. Yeah. I love, just math and all that stuff. You guys should know. But anyways, what's the answer for this? Sorry if I cannot answer your questions today. There were a lot of questions. It was a fun hour. It's not pi. It's not pi. You have to do this inside out. Inside out. Tangent pi is 0. So you are going to get arctangent of 0. And then arctangent of 0 is equal to 0. So 0 is actually the answer. That's why I told you this right here is not always true. It's only true if x is in between of this and that. Pi is outside of this interval. Pi is outside of this interval, so no. It's a pretty tricky question, right? Because it's kind of like that. But I will tell you though, if you do tangent of arctangent of pi, even though usually we don't put pi inside of arctangent, but pi is okay for all real numbers, this right here, you can legitimately cancel them, and that is equal to pi. All right, before we go, don't forget to check out check.com if you haven't done so already. Check out the QR code over there, and they have 24/7 support for all your toughest subjects. If you're taking Trig Precalculus, I will be here to help you guys next week. All right, we will have another online office hour next Monday from 6:45 p.m. Pacific time. Make sure you guys follow Check here on TikTok, YouTube, Instagram, and Twitch, and for more learning content like this. And remember here, we will be back next week, right? So maybe you guys can prepare some more questions for me, and I'll prepare something else for you guys as well. All right, any questions? Any final thoughts? Thank you guys for coming. Thanks guys for coming.